Seeing anything, let me explore some of the concept related to thread. Like when I talked about anything about thread in operating system perspective, you may find some of the concept like multitasking, okay, multi-threading, the difference between thread and the process. So these are some of the basic things you'll find when talked about thread. So if I want to say some point before coming into this part, that the task can be divided as a process as well as a thread. So you'll get process, thread, this term in your programming approach. So this process is a program. Thread is also a program. But the process concept you'll find when you are dealing with an operating system environment. But the thread concept you'll find when this thread will come above operating system using a particular language. So you can create the thread using Java, you can create a thread using Python. Okay. So, right. So this will come above OS. Inside an OS, you always use process program. And when it comes to thread, the thread concept above OS means above OS, we are going to install our JVM in case of Java, PVM in case of Python, and in that PVM, we are going to implement our thread program. So before saying anything else, let me see one point here with slides. I'll talk about this part. Process the difference between thread and process. Difference between thread and process. Assume I have some process like P1, P2, P3, P4. A multiple process. So multiple process interact with each other and complete some task. Okay, so I have multiple process that will interact with each other and complete some task. Similarly, for thread also I have multiple thread T1, T2, T3, T4. In thread applications also I have multiple thread, and this multiple thread will interact with each other and complete some task. What is the difference between process and the thread? First point is that if you go for process and operating system implementation, where for each and every process will share some resource. If I want to execute P1 process, we have to allocate some resource or memory for this P1 process as R1. If I'm going to execute one P2 process, I have to allocate some resource for this P2 process, that is R2. To allocate some resource from P3 process, that is said to be as R3. P4 process, that is said to be as R4. Like this way, for each process, I have to share some resource. When to execute a particular process, it will use that resource for the process execution. But in case of thread, it is not like that. In case of thread, when I'm going to execute multiple thread, all the thread can share a particular resource. Okay, that is the point that you're talking about here. We have to allocate some resource for each process execution. But on the other side, multiple thread can share a single resource. So if process cannot, that means process cannot share a resource, whereas thread can share a resource. That means process cannot share a resource. So if you see the difference, then for process implementation, we need I want to say process, it cannot share resource. Process implementation, right? Whereas in case of thread implementation, I can say like thread can share resource. Thread can share resource. So what is the advantage then? What is the advantage if thread can share? The advantage is that since process cannot share the resource, we need more resource for thread process implementation, and thread can share a particular resource. So that means we need less resource for implementation. Now, third point, you can say like since we need more resource, so process implementation is costlier. Process implementation is cost effective. Whereas thread implementation, it can share a resource. So for thread implementation, we have to implement low cost, right? So like this, we can define the concept between process and thread. Mainly process, we use operating system, but thread will come into picture. We'll use Java or Python. So most, right? But if I'm going to use this thread in our actual real life applications, then you have to talk about the concept of multiple threading, multi-threading. What is this multi-threading? How? So let me show something else for threading. Thread is lightweight and process is heavyweight. What does it mean by this? This term, lightweight and heavyweight. It is a very common term in our technical domain. Lightweight and heavyweight. Meaning by this lightweight and heavyweight. The meaning is like light. In case of lightweight implement lightweight. Let me give one example. I think it will be much more clear. Lightweight means no dependency on third party. No dependency. No dependency on other application. Heavyweight means whatever things you are going to say. I'll give you some example. Dependency on other. What does it mean? If you have done Java, in Java you will find one of the component called applet and swing. Using applet and swing, we create a user interface in Java. So out of that, we say that swing is SWI. Swing is lightweight and applet heavyweight. Why? Because the swing does not depend on operating system. The swing's code will run on above JVM, Java Virtual Machine. But if I'm going to execute a single applet, there is some operating system dependency. The applet program. That's why we say that applets are heavyweight, swings is lightweight. Same like take another one example. We have one of the component called one of the application framework called Spring. Spring framework is there in web application. Okay, we have another framework called EJB. We see that EJB is an heavyweight and Spring is lightweight. Same concept. EJB is heavyweight. Why? Because EJB has a dependency on the application server. You cannot write a single line of code, cannot execute a single line of code without application server. Whereas Spring can execute the Spring code without application server. That's why it's a lightweight and it's called heavyweight because it's a dependency. Same like we are talking about now, we are talking about thread. When you're going with the thread program, your Java virtual machine in Python virtual machine PVM is enough. But if I'm going with process implementation, process is dependent on your operating system. Okay, so that's why the process is said to be a heavyweight. So when you're going to execute some component, and if you find there is some dependency on some third party means based on an application execution, then we use this term called heavyweight and lightweight. Okay, so thread is a lightweight thread in Python, right? So right, so as we find that this multi-threading application is Python used a lot because now there's different process how we can create a Python thread, but you have to remember that you have to import one module called threading. Remember when you're using abstract class, you see here when you're using abstract class you have to import one module, right? That is ABC. When you're using abstract class you are going to import one module. What the module name? ABC. So when you're going to work on command line argument, there also you are going to import one module, sys, right? So we have small modules. Similarly, if I'm going with thread application, then we have to import one module. Name of the module is threading Python. So if I'm going to you're going to execute a Python thread, you have to work on this module threading. Okay, so for thread execution. So if I want to execute a single thread using Python, then what I'll write? So as I told you, first you have to import. Now there is a different process of writing thread in Python. You can use object-oriented approach. You can use procedure-oriented approach, right? So assume let's say this is our code. What I want is that I want to execute a simple thread. So to execute a simple thread, first import. You have to import threading module. After that, you have to print a particular thread name. So see here, when I'm going to execute a particular program, So that is actually the main thread. I'm going to execute any thread program. So that will work under main thread. So what I've written here, I've just imported one threading package and just print what I want to print. Print name of the currently executing thread. The name of the currently executing thread. So how I can print the name of the currently executing thread? That I can print using. So what is the thread name that I have to select from this threading object? Threading dot. See, currently automatically came dot get name. Something is there. Current thread dot find. Okay, get name. So if we execute like this, save as. I want to show you that thread, one thread program, page1 dot py. Save it, then execute. So if you see here, currently executing thread equal to, what is the name of the currently executing thread? And see from here, execute this code. Name of the thread is main thread. That means just I printed. I'm not creating any thread program here yet. So I've just printed import a threading module. And from the threading module, I want to see the current thread name. Should is printing it as a main thread, right? So if I want to, if I'm creating a particular thread program without using file, so in that case, I can see here that it is pointing out if I'm going to print any particular thing that is working on a main thread under PVM. Details, if I'm going to select threading dot current thread dot get name, using that I can get a particular thread detail. So also when I'm going to execute a particular thread, that comes under the main thread. So how I can create a thread program in Python? I want to create my own thread program in Python. Okay, I'm saying how we can create a thread program in how I can create a thread program in Python. So if I want to create a particular thread program in Python, so there is three process. Remember this, three way of creating thread in. So what are the three way creating a thread Python? What are the three different way? So that three ways we'll try to explore one by one. First one, I want to create a thread, create thread like using a particular class using class, thread class. Okay, so or let's start first. First, I want to create a particular thread without using any class. Create thread. This is a OOP without using any class. First point. Second thread, I want to create creating a thread extending thread class that you can do. Create thread extending thread class. Another process, create thread without extending thread class. There are three approach how we can create a thread in Python. So let's explore all of them one by one. Fine. So without using class, I want to thread. That means POP. Persistent programming. So as I just now told you that I have to get a thread class. So this is without using class. There is no class. That means what? I have a method and I have to call that method. So define a particular method. Definition. Right. This is my method name. No self sentence is not inside a class. So just now I told you that for your thread, you have to import package threading or from threading import start. So I'm just importing that threading package. Okay. So inside a method, what I have to do? I've defined one method. Write some code to print to start a particular thread. Right. So print first something. What do you want to print? Something like this is right method and the corresponding thread is said to be as thread. Now this how I'm going to get this thread here. You have to get this thread from this threading. You can write threading.current thread.get name or current thread. Okay, dot get name. Or if you want to, so it's the main thread only, right? Now I have to say you here. Like I have to create a particular thread, right? So how to create a thread? You can write T equal to thread. T equal to thread. Okay, and you remember this, it's implemented slightly different from Java. And I'm creating a thread object. So this is a function is written when writing T equal to thread, and inside this thread constructor I want to use, let me write inside the thread constructor target equal to right. When you target equal to right, that means this is the method. I'm creating a thread object that I parameter target equal to right. That means this is the method. That means the main thread create the child thread in this line. Main thread create child. How you can define that main thread is creating child thread here? You can see this example itself. This is a particular method. Here I'm going to create a particular thread. After creating thread, what I should do? I should start this thread. P.start. I started. And just print here something. Print hello. Something else. If you want to execute this code, now if you see here, this is your thread. And you're printing something, print hello. Here also you're going to print something. Assume you're printing this. Okay. Save and execute and check how this thread is running. This is your thread program. This is the method that we have written. And inside this method, you're printing something. Fine, no issues. So what you're going to do, I'm going to create a thread. Now, if you see when I'm creating a particular thread, here I'm reading target equal to right. That means it is going to execute this thread. And who is creating this thread? That is creating my main thread. Now let me see it first. Print. Save it and execute. Okay. This is not a class, right? It's a method. In case of POP approach, following. So when I'm creating this thread, after that you're starting this thread, printing something. It is in the outside class. Now you can see here it is not getting this thread. The current thread it cannot sense, right? So one option is that
Uh,
heading.current thread.
Amitabh, sorry to interrupt here.
Yes,
Actually,
please.
there's a typo in current. It's 3 hours you have written, and it should be 2 hours, right?
Which one?
The, the one where your cursor is blinking right now. The current underscore thread. Uh, current underscore thread. It's 3 hours. It should be 2 hours, right?
Okay, this one you're saying.
Yeah, yeah.
It's 2 hours. I don't think it is. It is single only. It is single.
No, no, the R's, not the underscore, the R. Current. It is CUR triple RENT. What you have written. It should be
Okay,
CU double
okay,
R.
okay,
Yeah.
okay. Yes, got it. Just save this. Import threading. Import star. Okay, file. Save all. Or file save as. th2. Hi. Okay. Now here it should be available now.
In line 19, you have also still triple R. Needs to be also corrected. Yeah, there.
Okay. Okay, sure. Do one thing. Don't use this and directly use there. Threading dot current thread and here threading dot current thread and save it. So t dot thread. So you can write here threading dot thread. Fine. Now, if you see this code that we have written, I'll show you all the things step by step from where things have come. Just execute. Let's see here, please. This is a write method. Threading.current thread.get name. It is written threading.current thread. Okay. And hello equal to Shiva. Now we are using threading dot current thread dot get name. Now first you created this thread, target is right. You have started the thread. Now you are going to print hello equal to. So hello equal to printed. This is the right method. This is the right method. and name of the thread is this. To slide change into this, like 1 minute, 1 minute. Everything I have done inside a method. Fine. Now things will be okay. I'll save all. Yes. Now it is fine. So if you see this code, this is a method or function. This is a statement that is outside function. Fine. Now, when I execute this, it's a thread program. When I execute this thread program, this is outside function. That means in this example, if you see in this example, this part is actually, this is outside function and this is the main method. Main method always, in case of main method, it always start the child method. Main thread always start the child thread. Now these examples, I don't have any class implementation, but this is your child thread. This is the child thread. How to get this is the write method. This is the main method. Execute once again. Hello equal to main method. This is the main method, right? And then when I'm going to write t equal to threading dot thread target equal to write, this is actually going to start the child method. This is statement. Name equal, it is given thread 9. Assume. Let me close this. Hmm. So we can slide. So if you see here, actually it's printing it in here differently. That's why it's actually this is actually the thread 9 that it is showing here. Now here, this is the main method, and this main method, when I'm going to, in case of thread program, this main method is starting the child method, child thread, and this child thread, what it is going to do, it is going to execute the method called write, right? And you can see that child thread is going to execute this method called write. So when I'm going to create a child thread, what I have to use in the thread constructor, I have to write the target name equal to write, which method I want to execute as a child thread. Now in the thread program, we have the package called module called threading. We have to use this threading module to execute a thread program, right? Now, if you see this small program outside, this is actually the main thread, and main thread will always use to start the child thread. Now, child thread started, but who will child thread started, right? And this is my main thread. So because it is outside, right? So now let me uh, execute the same program, slide. Using some other example, it will be much more clear. Let me take other example for coming here. For the time from here, I can come into a particular conclusion that main thread will always start a child. Now this the example that we have done in this example without using any class. We have not used any class in this example. Okay, and the second example, let's try to explore into more into this. Control T. Let's try the second example. Explore on this. I'm talking about second part. That is, I want to create a thread extending thread class. So if I want to create a thread extending thread class means what? Again, I'm going to create a thread, right? So assume my thread class name is my class name is vehicle. Class vehicle. Vehicle is my class name. I want to create a vehicle class as a thread class. Is it a thread class? No. It's a class, normal class. Now I want to convert this class as a thread class. Only when it is going to extend thread. So how it is going to extend thread? Then it's going to extend thread. So now it is a thread class. Now it is a thread class. Fine. Second point is that inside, now this is an example, so I'm going to write extending thread class. So in that case, I have to override a particular method from thread class to my class with my own code. Again, I'm saying, if I'm going to create a thread class, if I'm going to create a thread class, extending thread class, then I have to override a run method from thread class to my class with my own code. So I have to override a run method here. So definition, run, self. This is the run method. And all the logic I have to put inside the run method. So what logic I want to execute for the time being? I want to execute like I want to print some numbers in a loop, something like that logic. So I can use for loop for I in range 10. Okay, and it. So what it will do in the run method is going to print it will move inside a loop, right? Right, it will move inside this loop and print the value of I, right? Now here it's a thread program, so I have to extend thread, import thread. So import thread. Now we generally use this option from threading, import star. So we should use this option and it should work. Right, so in this example, I have created a thread class and I've overridden the run method from the thread class to my class with my own code. Right, so this is my thread class, and this is outside thread class. You can print something like you can, but the point is, let me write some code first for this child thread only. This is your run method. Then in the child thread, let me complete first in the doc. This is a child thread. This is a child thread. And if you want to print this child thread, you have to use current underscore thread dot get name. and this is your vehicle. You can define as a child thread, because so why child thread? I'm saying the main thread is always main. Always main thread will start your thread. Okay, so I want to create the vehicle thread. Fine, create T1 equal to vehicle. So I've just created one vehicle thread. Then I want to start the vehicle thread. So what I can write T1 dot. I'm starting the vehicle thread. Fine. And on the other side, this is my main thread. Main thread, you can print something like print. This is main. Yeah. And if you want, I have not printed anything, right? Print I. Print, you have to print some number I. Or, so let's see how it is. Control C. Control V. File save as. You can put it inside th3. Hi. Okay. Now this is the import package, and this is your class. This is your method. Inside a method, you are using for loop. For loop, you have defined just a printing something in the for loop. This you have written inside the method only. You have started your thread object. You have started your thread, and this comes under main method. This is the main outside class method. So it is has some difficulty to get this thread. It should work. Okay, it's not extending this. Fine, in that case, I can manually write this like import threading and use here threading dot thread. So file save all, and if you execute this code, what you find just here, this is a main thread. And what about your child thread? That is not yet started. The run method. Inside run method, you have a for loop, right? So you're not using this. Print file save all and execute. So I've started this thread, right? T1 to start, and this is a vehicle. So this is the main thread. This is class vehicle. And if you see here, I've created an object of vehicle, and then I've started file save all. And that you have written inside the run method. I'll say, well, it should work.
Amitabh, one doubt here, that who will be
Okay.
calling the method run? If we have created an object for the class, then we have started a thread, but the object should call the method run, right?
No. When you start the thread class, when you start the thread, then automatically then run method will be called, because in case of thread program, when you start a particular thread, what we are going to write is that, yeah, you are writing uh, uh, you're creating a thread object, and then you're going to start this thread. So this will automatically call the run method. Check 1 minute, please. I'm just saying, yeah, yes, it's working fine. See, the point is, see, the thread concept is that in this example, we have created this is my thread class, vehicle. So vehicle is my thread class. How I can say that vehicle is a thread class? Because vehicle is extending the thread class. Now thread class contain one run method. Thread class contain run method. So when I'm going to create a thread class, I have to write some logic inside the thread class. So that logic we have implemented, we should always implement that logic inside the run method of the thread class. So we have written some logic in the run method of the thread class, saying that this is a child thread, its name is this. That is they given some thread 11 or something like that. This is the name of the particular thread that is running. So this is my thread class. Now what I am doing, first I have creating an object of vehicle. So what I've created a thread object with T1. T1 is a vehicle class object. Vehicle is a thread class. So T1 I have created an object of a thread class. Then when I'm calling T1 in case of thread, I'm just saying you in case of thread implementation, you should call the start method, and start will call to the run method. Now you will say that why like this. I'm coming into that. When I'm coming with the life cycle method, you will come to know. For the timing, just I want to say that when I'm going to start a particular thread, I should always use t1.start, not t1.run. Who will call run method? If I start t1.start, we have the concept of thread scheduler. I'm coming after some time. The thread scheduler will start run method. So as per thread API, Python thread API specification, we should always call the start method, then it will call the run method. Why I'm coming after some time? So in this example, if you see, we have created a thread class. That thread class I have started. Thread class I have started. I can see the thread class I have started. Now here, how many thread we have? Here we have total 2 thread. This is my child thread, and this is the parent thread who is actually starting the child thread. Under parent thread, the child thread will start. Now I have to do I have to show it somewhat. Assume I'm going to import another one module here. Just see this. This is just for import time. So if you use this time, and here what I want to say is that time dot sleep one. Time dot and sleep. You can use some second, 1 second. I want to sleep. You write like this. I think it will be much more lookable. Just see here after 1 second is going to the sleep phase, and and the thread gets executed, right? Okay. Now, if you see this execution, first, so where is my main thread? This is the main thread. This is main thread. So this is main thread. So this main thread gets executed first. Main thread completes its execution first. Then child thread is going to complete one by one. Once again, I'll show you. Just see this main thread executed. This is main thread is done, and child thread gets executed step by step. Right. So in case of normal thread application, I use the sleep method just to show you that flow. That's why. Just to show you this flow, I've just shown you that. Right now, right. Okay. Now, if you see that in this example, so first main thread completes execution, and then child thread is completing step by step. I use the sleep method just to show you the flow. Yes, first main complete. If you're not using sleep method, if I'm not using sleep method, then also you can see this flow. Execute, and let's see here. First main completed, then child completed. So in case of thread application, we have main thread and child thread. In generally, main thread will complete its execution first, then child thread will complete. Generally, this is my example, right? What we find point here. Generally, main thread will complete its execution, then child thread will complete. This is a normal flow. First main thread will complete its execution, then child thread will complete. Right? Okay. Now in this examples, I have only two threads, main thread and child thread. Now what I want to create another one child thread. What I want is that I want to create another one child thread. Okay, so what I'll do is that, just see here please, I want to create another one child thread. Let's see, I want to create E2 equal to vehicle and P2 dot start. I'm starting another one child. Now I have how many threads? I have total 3 threads. I have total 3 threads, 2 child thread and 1 main thread. 2 child thread and 1 main thread. Okay, so let me execute. So just see here, main thread, this is main thread completes execution, then child thread 16 and child thread 17 gets executed. Right, so this child thread 16 and child thread 17 gets executed. This 2 thread that gets executed step by step, right? This is the name of the thread, right? So the thing is that first child thread 17 completed, fine, then child thread 16 completing. I have 2 thread, right? If you don't want to give the name of your thread, assume I don't want to get the name of my thread, you can write here, this is child thread car. Right, you can or in this example I've given the name. Okay, so this is a vehicle, right? What I want to say that, let me check that vehicle is coming or not. T1 dot Yes, it is there. So what I want is that, let's see, this is child thread, it's fine. Child thread. And I want, for the first thread, I want to set the name, t1 dot set name. I want to set the name for the first thread as car. Okay. And for the second thread, I want to give a particular name as t1 dot set name, okay, as bike, right? So I have created two. So what I have done using this set name, I have just initialized the name of a particular name of my thread. Okay, using set name, I have just provided the name of my thread. So, and get name, if I want to get the name, then how I can use, threading dot parent thread dot get name. Using that, I can get the name of the thread. So what if you execute, just see the output, please. Just save it, file save all. So bike is there. Okay, shed name I have used bike. Okay, it's a naming problem. This should be T2. This is T1, this is T2. Okay, so just execute, sorry. Okay, now just see here, please. So just see here, the main thread completed its execution first, then car, bike came, first car came 2 times, then bike thread gets executed, then again car thread gets executed. That means first car thread executed 2 times, just see here please, then bike thread completes its execution, then car thread completes its execution. So the thread, first of all, can assign the name of a particular thread using set name, and name of a particular thread I can get using get name, right? So what you find, another one point about thread is that we can set and get the thread name using set name method and get name method. Fine. Okay. Save it. So I can get, now the point is that assume I don't want to move this under 10 times. I want to move it 100 times. Okay. Let me check if I'm using this range as 100 times, what is the output? Let's execute and check. So just see here, what is the output in case of 100 times? Just see here, please. I've given it 100 times. When I've given it as 100 times, just see it started from here. Car executed. Main thread completes the execution. Just see here, please. Car executing. Again bike came. Again car came. Again bike came. Again car came. Bike came. Car came. See here, bike, car, again bike. Again car thread gets executed. Again bike thread gets executed, right? Right? Like this way. So the see here, please. I'm executing 2 thread. One is car thread, another is bike thread. And if you see the output, the threads are running in their own flow. Correct? If you see this output, the threads gets executed in their own flow. I want to execute some thread, and the threads, there is no order. Just here, where is the order? Sometimes car, sometimes bike, sometimes car, again sometimes bike. So there is no proper order. correct? I want to execute some thread based on some order, but the threads are moving in their own flow. Just see here. Now, why it is like this? Then what is the use of writing a thread program if then they cannot execute based on the developer instruction? They're running in their own way, right? So why? If you have not only do this, just try to execute it in different operating system, you will get a different output. First 3 times, if I'm going to use 2 times or 4 times, okay, and execute it, file, save all, and execute. Check the output. First bike completed, then car completed. There is some order. Yes, first bike completed, then car completed. Now then I'm going to use 10 times. Again execute. So just see here, first car completed, again bike in between, again car, again bike completed. So there is no proper execution of thread. Just see here. Again I'm using 30 times. Just execute. See here, please. First car, bike, car, bike. So there is no proper execution of the child thread. But in all this execution, you can see a main thread completed first. Main thread completed its execution first. But the child thread's order of execution of the child thread is not under the control of the developer. They are moving in their own flow. Correct. So that is the point here that I had to talk about. If I'm going to write some thread program and those threads are not executing based on the developer instruction, then what is the use of writing thread program? Right? So that is the point that I'm saying here is that, see, why it is like this? Why the threads are moving like this? Some reason behind that. The reason is that the complete thing, see, this is my operating system. My system, I have operating system is Windows. Windows, for me, the operating system is Windows 10. For me, the operating system is Windows 10. Okay, so above this Windows 10 operating system, we have installed one PVM, Python virtual machine. Okay, see, so these 2 threads is running under Python virtual machine, T1 and T2. Both the thread is running under Python virtual machine, T1 and T2, that I'm going to run. Now here, you have not used this T1 thread. We started or car and bike, and you have this T2 thread that also you have started. Now if you see here, both are thread you have started. The thread, fine. Now what is the problem? Why output is not coming in order? The reason is that the thread that you are executing under Python virtual machine, the Python virtual machine has one component. Its name is thread scheduler. Thread scheduler. Thread scheduler is a particular component under whom this thread are running. How thread scheduler will tell you based on that T1 and T2 will execute. So if you see this code, first T1 thread started because it will start from like this. First T1 thread will start. So first thread scheduler will get T1 to start. Then T2 will start. Then thread scheduler will get to start T2, right? right? So like this way. So first T1 will come, then T2 will come to thread scheduler. Now, how this thread scheduler is giving priority to this thread, based on that the thread will execute. Problem is that there is another one component under operating system. Uh, uh, this is a thread scheduler inside your PVM, and we have a thread scheduler inside operating system. So when I'm going to execute multiple thread, those multiple thread first it will come under PVM thread scheduler. Okay, and from PVM thread scheduler it will come to your operating system thread scheduler. Now how operating system thread scheduler will give the priority to this thread, based on this two thread will execute, not based on the priority provided by your PVM thread scheduler. This is the reason why the threads are not executing based on your instruction. They are moving in their own flow. Why? Because when I'm going to execute any thread that comes under Python virtual machine thread scheduler, but in which, so first Python virtual machine thread scheduler will get T1, then Python virtual thread scheduler will get T2. So the thread should be executed first T1, then T2. But it is not like that. The control will move to operating system thread scheduler, and how operating system thread scheduler will decide, based on that they will execute. So now the question is that I have written some thread program, and these thread programs are not executing based on my instruction. Then what is the use of writing thread program? Right? So what we have to do is that we have one concept called thread manipulation function. We have one component called thread manipulation function. We have lots of thread manipulation function. So like we have a group of thread manipulation function. So if I want these threads to execute based on my instruction, then I have to use this thread manipulation function, because how this thread manipulation function will give the instruction to the thread scheduler, based on that those thread will get executed. In this current example, when I'm going to execute this thread, there is no thread manipulation function. We have not used any thread manipulation function here. We are just creating one thread class and started that thread class. We have not used any thread manipulation function here. So if I want this thread should execute based on my instruction, based on developer instruction, then I have to use some thread manipulation function. So what are those thread manipulation function? We have some thread manipulation function like sleep is there. We have is alive. We have jot. Then we have like this way, lots of thread manipulation function is there. You can, if you go to the API documentation, you will get lots of thread manipulation function like acquire. Acquire is there. Then we have another one thread manipulation function is there, that is called we have done one thread manipulation function that is called release is there. Okay, then we have wait is there. We have notify, same like Java itself. Wait, notify all. Like this way, multiple thread manipulation function is there. Okay, so if I want to start the thread, then I have to use this thread manipulation function. Then only those thread will work based on my instruction. Else, we don't have any control on those child thread. They will execute in their own flow. Using this thread manipulation function, we can have control, or we can have control on the thread scheduler, so that based on my instruction, this thread will get executed. Fine, right? This is one scenario. Okay, so so if I have to be a very good thread program, if I want to work on thread programming, I should know how to use this thread manipulation function, right? Okay. Now, so in this current code that I have written, I want to use one thread manipulation function here. Okay, so I want to use, already I have used one sleep, right? So sleep is one thread manipulation function. So based on thread API specification, always you should start the thread. So when you're starting the thread, then only your thread lifecycle start phase will start. Fine, right? So when it started, then it will come to runnable state. So when it will come running state, so when this run method gets executed, then it is in running state. Okay, you have started the thread, but when your run method gets executed, then you are in running state. So that is the difference between start and run. As per thread API specification, we should always start, then only thread scheduler will restart the thread and add some functionality inside your thread object, and it will come to the runnable state. And when this run method gets executed, then your thread came under running state. Fine. So that is some differentiation here, right? So now thing is that I told you about thread manipulation function. Right. So we should know how to use this thread manipulation function in our thread program, right? How we can use this thread manipulation function in our thread program, right? So execute some thread manipulation function. I want to use one thread manipulation function here. Let's see, use one thread manipulation function like join. We have one join method, right? See, I've written here join. Why I need this join? Sleep already I got. Sleep already I got, right? If I'm going to use sleep, just see here, I'm going to use sleep. File, save all. I'm using sleep, save it. File, save all, executing 10 times. Right? So file, save all, just execute. You can see first car, bike, car, again bike, again car, again car, again bike. So they gets executed. And those child are executing in their own process. So what you find in the normally, that first main completed, then child is going on, right? So first main thread completed, right? Now what I want is that I want first child should complete, then main will complete. Again, I'm saying when you write a normal thread programming, you will find that in general first main will complete, then child will complete. But what I want is that I want child should complete its execution first, then main should complete. If you want like that, in that case, what you have to do is that you have to use join method. So what I'm doing, I'm using t1 dot join and t2 dot join. Using join method, what will happen? Join, this will first child, this will first child, it will bound to complete the child first, then main will complete. So let's see what happened. Execute. Just see here, please. Main not yet completed. Just see, please. Child gets completing. Right? Main not yet completed. See here. First child gets completed, then main gets completed, right? So if so, now this is a thread manipulation function, right? It will follow the instruction, right? Now so that is the point about join. Okay, so I can write like so that means using join you can control the thread execution. And if you are going to use join, then first child will complete, then main will fine. So using sleep, what you're going to do, make the thread in sleep state or wait state. Is alive. Using is alive, you can check the thread status. Just check whether we can check the thread status or not here. So if this is your thread, so before join, I want to check the thread status. Fine, is alive. So you can write here t1 dot t1 dot is alive method, as well as t2 dot is alive. This is going to return a boolean value whether the thread is active or not. It is going to return. So how we can use using print. I can check the status of T1 thread, and we can using print and check the status of T2 thread. Okay, and when you've got the status, so that I want to check both the status before calling join as well as after calling join. Okay, you can see the status of a particular thread. Let's see how it is. File, save all, and execute. Just see here, please. So first we got true. So before starting the thread, we got the status for both the thread as true. You can see from here, true and true came 2 times. You can make it 3 times. Okay, file, save all. You can see the output properly. Just see here. So before starting the thread, we got true and true. This is coming due to some other problem output. So this is true comes, right? And after executing the child thread, we can see both the thread status is false. That means child thread completes execution, then main thread completes execution. So using isAlive method, we can check the status of a particular thread, right? Okay, now here we have some other thread manipulation functions that you can use for your thread program, right? Okay, now this is one example of I'm coming into the other function step by step. Now this is the second approach how we can create a thread class. This is second approach we talked about, right? Now I want to see the third approach. I told you 3 approaches there to create a thread class. 3 approach. First one we have done without using any class. Yes, we have done this one without using any class. Second approach, creating extending thread class. I'm creating a thread class. Yes, we have done just now. Third approach, you can create a thread without extending a thread class. Okay, so let's see this third approach, how we can. So the first approach is that I'm not using any class. See the difference. First approach is without using any class. This thread class I'm going to create. Now it is saying that without extending thread class, I'm going to create the thread. Okay, so let's see this third approach. We'll see this third approach. Okay. See. This is my third approach. 3. Get a thread without extending a thread class. That means I can use class concept. I can use the concept of class concept. This is not a P. That means if you want to see much more specific this example, then I want to say that this is an approach that is called using POP, procedure oriented programming. This is the approach using OP, and this is an approach using OP. That means the last 2 approach I have to use class. Number 3 is saying without using thread class I have to do. So let me see how we can do it. Right. So let's try this and create a thread without extending thread class. Okay. Now here so just see here please. So what I'll do is that just now we have created that vehicle program, right? In same program I'm going to execute, but without using thread class. Same program will do it. Okay. So then it will be much more. Let's see here. We create a class vehicle. Right. So inside this vehicle class, assume I'm using a constructor. Okay. Definition in it. And you can use one argument constructor that will give some message. Okay. And that message will return like self dot str equal to str like this. Fine. It's just a parameterized constructor inside the vehicle class. Okay. So if you see, this class is not extending thread class. So if it is not extending thread class, then I don't have to override run method. Not required. Right. So I have to write some logic, right? Thread logic. Where I'll write thread logic, we have to write inside an user defined method. Assume its name is drive. Take some other user defined method. Dev drive. This is an user defined method. So if this is an user defined method, so you have to define this drive where I want to write some logic. What logic? Same logic you can use, that logic that I have used last time. Like for I in range 10. Right? And in this range, I want to use, can you sleep for 1 second, as we have done last time. That sleep you have to call using time module. Time dot sleep on. And here also you have to use, import that time, right? Import time. And not only that, you have to import from trading. Import start. It should work. Let's see it is working this time or not. Okay, now class is ready. There is no thread. Still now my class not extending thread class. Right. So if you want to print here some that string that is being given, can print something like this is child, right? And you can use here this instance variable, right? Self dot str. Okay. Now what I have to do now, I have to get two thread, right? Okay, so I'm getting two vehicle object. Now it is class only. So let's get two vehicle object. First one is obj1 equal to vehicle, and if take, so assume first vehicle object is a car. Okay, I'm getting second vehicle object. This is obj2 equal to vehicle, and assume this name is bike, right? So inside the class you have two vehicle object. One is car, another is bike, right? Okay. Now here, if you see this, now still now in my code, I'm not use thread class, right? Now what I have to do, I have to create thread object. So I am going to create a thread without extending thread class. Yes, I'm creating a thread. Still now my class is not extending thread class, right? Now I have to create a thread. How I can create thread? So first thread assume th1 equal to thread, and here target equal to, using target we want to give the method where the thread logic will execute. Okay, so target equal to what is the method name? Drive is the target name, right? So how I can call this method drive? Using object name called obj1. That's it, right? Same like that. I want to get another one object. Assume the second object is th2 equal to thread. Target equal to 2.5, right? So I'm getting thread object, first thread object for the first vehicle car, and second thread object is the first second vehicle bike. So I have created thread object without using thread class, without extending thread class, right? So if I have created this thread object, what I have to do? I have to start thread one, th1 dot start, fine, and then th2 dot start, right? Okay, so this is my child thread I have started, and as this is my main thread. The main thread will come outside, and for main thread you can write like print, this is main thread, this is main thread, that's it, right? So let's execute it. It should work. There's no problem, everything is correct, only noise is fine. Okay, fine, it should work. Let me check it's working or not. So this is a third approach how I can create a thread class in Python. Okay, fine. Okay, so let's get another one. So now file, save as, make this class name as th4. 4.py and just add this file save all. And this is my class. That class, this is my init method. Init method is used to initialize this constructor. Then I have another one class, and inside this class, zip method, and this is the code that we have written inside the drive, right? Okay. So next, what you have to do, we have created both the object, right? Now we have created both the object, and using both the object, we have created two thread object. One is called T1, and then you have started both the thread, and then this one main thread. So you can see if you're creating a constructor, you have to define that constructor, right? Okay. So file save all. Now this is these problems would not come. I think possibly this ID, some syntax is not working. Due to that, it is working. Code is correct. Okay, due to some syntax, well, this is not actually this is not getting the threading package. It's fine. No issues. We have to use alternative. We have to import for threading. Using import threading. So using this threading, you can call the thread class module. Right, so it's working fine, no issues, no error. Fine, good. Now file save all and just execute with the thread. Just see here, first main thread completes execution, then child thread is completing its execution. So this is working fine. First main thread and then child thread gets executed, and it's working fine, no issues. And it's printing the thread name also, and properly it is working. Last time it was not working properly because we have not used. Okay, we are printing the thread name differently. This time we are printing the thread name, taking an argument from the user. It's the best option, no issues. Right, so this is the third approach, how we can create a thread program. Fine, so we got three different approach how we can create a thread program in Python. Fine, okay. But these are the basic, very basic and introductory thing. Now, when I'm going to work using thread in real life application, you will find the thread as jobs. Okay, in the using Python advanced module you are going to use, you'll find them as a jobs. So there you will find that some of the concept like how I can when multiple thread is working, then how I can synchronize the operation between multiple thread. That is, when you go to the advanced application of thread in real life application, some of the scenario will come like how to work on thread in synchronization as well as inter-thread communication. These are the two major and bigger environment where we have to work in real life scenario, that is thread synchronization and inter-thread communication. These are the two bigger scenario that you have to face in case of real life environment, right? So that is our next topic, like how we can implement thread synchronization as well as inter-thread communication. So we try to understand two example based on this. That is the next topic. And okay, and after that we'll move with the next part. But so let's explore into this thread synchronization and inter-thread communication one by one. Let me come into this thread synchronization first. These are the actually major two domain where the complete production environment threads are running, executing every day. Okay, so let's try to understand this thread synchronization in details. Okay, so now this thread synchronization is same for all the language. In Java, how we are going to define thread synchronization, in .NET as well as in Python, same. But to implement the concept of thread synchronization, a different language is using the methods, different name methods they are using. The actual concept is same. So how that concept it is, just see here. What does it mean by thread synchronization? If I have to define thread synchronization in a single line, then what I'll say? I'll say like at a time only one thread will access a resource. This is the line I want to define to talk about thread synchronization. One line I want to define it. At a time, only one thread will access a resource. So let's explore the idea. What does it mean by this? I'll also give you a real life example itself. Before coming into that, let me just explore this idea. See, I have one thread called T1. So in your application, T1 is one thread, T2 is one thread, T3 is another thread, T4. So we have total 4 thread. So 4 thread is executing simultaneously. So this is the main thread. This is the main thread. Assume main thread. From main thread, all the 4 thread, main thread have started in Python, all the 4 thread, and 4 thread is going to execute its operation. This is started its operation. It is started its operation. It also start going on with its operation. It also going on with its operation. 4 thread started its operation. Now, when 4 thread starting its operation, then assume they need some value, or they have to access some value like your object, or assume for the timing I'd say particular value count equal to and some value they want to access. Again, I'm saying I've not given any real life scenario. After this discussion, I'll come with a real life scenario, how this thread synchronization work in real life scenario. I've just, for the timing, I told you that the main thread have started fourth thread. Main thread have started fourth thread. Some of the thread you find that this thread is running on the background next 2 days. It will continue run. Some of the threads you'll find next 4 hours it will continue. Some threads you'll find it will continue next for 7 days. Okay, some thread will continue just 1 hour. It will execute and complete the task. So when multiple child threads is working simultaneously, during that it need to access this variable. Now T1 have accessed this variable. Again T2 came, T2 access this variable. Again T3 came, he is going to access. Again T4 came, he is going to access. So the thing is that it will be an haphazard. The thing, again I'm giving you the scenario. During lunch time, we have to get the food from the counter. How? Using the coupon. But if there is no coupon system, then what will happen? All the employees will come at a time and they wanted to collect food, and it will create a haphazard situation. So that so what you have to do, at a time only one thread should access this resource. At a time only one thread should access this resource. So if T1 is accessing, T2, T3 and T4 have to wait in the queue. If T2 is accessing, then T1, T3 and T4 should have to wait in the queue. If T3 is accessing, then T1, T2 and T4 should wait in the queue. So that at a time only one thread should execute this resource. This concept is called thread synchronization. That means when one thread, how this thread synchronization will work? Talking about how thread synchronization will work. How thread synchronization will execute. How means, the thing is that first step one, I'm talking about step one. Step one will happen. Step one, assume, I'm just saying the step, assume T1 first, T1 will access the resource count. Step one, T1 will access the resource count. Fine. So T1 will have access to resource count. Fine. First step. Now when T1 is accessing the resource, what T1 will do? T1 will lock the resource. Step 2. We have lots of technical terms, semaphore, mutex. I'm coming into those things. Number 2, what T1 will do? T1 will lock the resource. Lock the resource means he'll lock by T1. So when this resource locked by T1, why it is going to lock? Then so that no other thread should have access to this resource. That's why when T1 will first access the resource count, it will lock the resource. So what is the advantage when it is going to lock? If you lock a door, no one can go inside the house, right? So that is going to lock that resource so that everyone, all the other threads have to wait in the queue. Fine. Okay. Next, step 3, what will happen? Step 3, T1 have locked a resource, then T1 will complete the task. C1 will complete its operation using this resource. Step 3, T1 will complete operations using the resource, right? So once T1 completed its operation, once T1 completed its operation using this resource, T1 will, what it will do? Lock released by T1. What it will do? T1 will release the lock on the resource. So next step, step 4. T1 will release the lock on the resource, right? T1 will release the lock on the resource. Fine. If T1 is releasing the lock on the resource, now this resource will be available for other thread. Now, in this other thread, we will get priority. That thread is going to access the resource. Assume T3 got priority. So T3 will access the resource. Again, T3 will lock that resource. T3 will complete all the operations using this resource. Then when the operations completed, then T3 will release the lock on the resource. Then based on the priority, other threads should have access to this resource, right? So this resource is said to be as an mutex, and the surrounding area is called monitor. This type of technical terms is there when a thread will access that mutex inside the monitor. So this type of things you'll find. So I've told you differently. This is the main scenario, how the thread synchronization will execute. Fine, guys. Anything else you want to add? Okay. Now this is given the examples of thread synchronization. Now how this thread synchronization will work? We should give one real life example, right? So let me give one real life example for ticketing system. Last time we have used banking system. Okay, let's give an examples of ticketing system. Ticketing system means that ticketing system means like, give you an example, then it will be real life example will be much more clear. Reservation system. Reservation system. So assume you have available at a particular time your resource is available set or berth. Available berth. Okay, available berth is assume you're moving via train from one location to another location. I'm talking about train reservation, assume, and you have available berth is 2 time. So this is the resource. Available berth and at a particular time, this is a resource. And this resource reservation should be done by 2 persons. The first thread, assume is Navin, first thread, and the second thread, assume is Max, second thread, and both the thread want to access this resource, right? Both the thread, because both want to do the reservation confirmation, and it is confirmed. So both want to access this resource, or assume I have only one set. a time. So both want to access this resource, both the thread. Assume when Naveen got access to this resource, when Naveen got the birth, after that, this should be 0. There is no birth. When Max will going to get the resource, he will not get birth. Or assume you have 2 births. First, Max got access to this resource. He will get the birth. Then that he lock this resource. He will use this resource, means he will get 1 birth. Then he will release the lock on this. Then it should have 1 birth. Then Naveen gone. He will lock that resource. He will get that resource, and then he will release the lock. Then total number of available seat is 0. So like this way, this thread synchronization will work. This is a small example of reservation system, how Naveen and Max is going to do the reservation for a single set. One person will get, other person will not get, or when one person got the reservation, then that birth should be minimized by 1. Then the second person should get the reservation, right? So that should work simultaneously, right? So how I can implement a thread program using Python, where we can see the example of thread synchronization using Python for a reservation system, right? So so let's create one thread. Let's create here. So assume create one class first, okay? Class is reservation. Okay, this is a class. Okay, so inside a class we can define one default constructor, a parameters constructor, and define parameters constructor. So this parameterized constructor have an init, and you can use here self comma available is that resource, and you can instance variable and define this available equal to, you can make it like this. It's an instance variable, right? Okay, now we should write one method that where you are going to implement that reservation. So define one method, def, and name of the method will be like reserve. This is the method. So new self comma me some boolean variable if you want. Take some boolean variable as wanted, something like that. Now define this method. How we'll define? So when the thread is going to access this resource reserve method, what it will do, he will first check the available details. So available details should be printed, right? So print the available details, available birth, available birth equal to self dot available, right? Okay, so if any one of the thread is going to access this method, he get the available birth. Fine. Now, if that availability is greater than wanted, right? Wanted is another variable is there. So if that availability is greater than wanted, then only he will get the value. Availability 2, wanted is 1. Okay, availability is 1, wanted is 1, like that. So you can write a logic like if self dot available greater than equal to, I'm giving wanted, greater than equal to wanted, then self dot available, self dot available equal to wanted. Else define, because in case of Python, after if else there is a colon. Else there is no what? Print no birth is available, like that. It should come, right? So if he got assume he got the birth, so here you can print something like who is going to, there's two thread, right? Who is going to access this, who is there actually, who is going to have that birth? You can print the name of the thread, right? So you can write like name equal to thread current underscore thread score thread dot get name for the name and just print that name. We want to do print. So already you know, right? Percentage D is for number, percentage D birth load head for percentage S, right? So then you have to provide that variable name like wanted name. On both the things you'll find it gets printed. Fine. Like this you can just print the details that you want need to be printed after this, right? Okay, now in the main class what we can do here is like here in the reservation class, right? And the reservation class I have to create an object of reservation, right? So obj equal to reservation. So when I'm going to do the reservation, if you see here birth is available 1 or 2, you can give, assume you can give one come inside the available birth is 1 coming inside the parameters constructor, right? So the available birth is 1, then first thread will come to access this birth, first thread will come, right? So T1 is the first thread equal to, I'm using the third approach to create this, thread, first thread will come. So what, then second thread will come T2 equal to, so first thread, second thread, first thread will come and he will call that
Brother,
reserve method. Yes, please.
yeah, just this T1, T2 are the number, the request that will come for this reservation, right?
Yes. So
Yeah.
first one, we can assign some name for them. So assume T1 is Raj and T2 is Navin, something like that. So how this T1 is going to call, so it is going to call which method? Reserve method, right? So reserve method, so for T1 thread, how it is going to call reserve method? Using an attribute called target. Remember target equal to our obj.reserve, right? And fine. Similarly, I can say for the second one, target equal to obj.reserve. Fine. Now for the thread, you can assign some name. Just now I talked about how to assign name. T1 dot set name, and assign some name like Raj, and take the second name T2 dot set name. And assume the name of this is Navin. Fine. Now after that, what you do, please start the thread. T1 dot start and T2 dot start. So it should work fine, right? Now it may give lots of error also. Let me check what error it's giving. So get thread class stage 5. Save it. Okay, now here constructor, import the package, right? Which package? The threading package I have to import. Let's see, that approach is not working here, so you can write import threading. And if you are using sleep, I have not used it. I should use sleep. So let me complete it first. Save this. Okay, so this is our reserve method. Right, so already I have executed this thread. Let me show you that one. May take some time. Let me show you the thread that I already executed. Not this one. File open. To check where it is. Okay, let's try. Now here, create a reservation object. The thread class is over. Thread object here. Okay, and both object name we have provided, and then we have started both the thread. Just save all, 5 save all. Now you see here, this is a constructor that you should define, and you're importing this threading package. Okay, and if you have defined and else should come in the same line. Okay, expected indent, so where it is. Okay, it should come if in the same line. Else should also come in the same line. So file, save all. Now we have to import threading. So threading, it's not generally extend. I don't know. Okay, let's check. Control C. You should import threading.current thread. You have to call this threading. This one also. So file, save all. So it should work fine. Require positional argument for wanted. Okay. Now reserve missing one argument for wanted. So this is my reserve method. This is the wanted. So where you are passing this wanted. Okay. So assume you can pass that as an argument from here. That argument you can provide as this value. And save all. A module threading has no attribute current thread. Okay, some spelling mistake. File, save all. So available Barth is 1. Barth allotted for Raj 1. Again Barth allotted for Naveen 1.
But why did not replace this percentage %D and percentage %S?
Yes, that
Should
I'm
have.
checking. Okay. We have to use here file, save all. Okay, sorry. No comma. Okay. Now if you see here, berth available 1,
Yes, perfect.
1 berth allotted for Raj, available berth is 1, 1 berth allotted for Naveen. So the thing is that it is not done properly. You see, we have available berth only 1. Then 1 berth available for Raj, again available berth 1, 1 berth available for Naveen. It is not working properly, right? So if available berth is already acquired by Raj, then it should be 0, right? So the thing is that this is the method. We have to make this method synchronized. If I make this method synchronized, then this output will not come. Means when Raj is going to access this method, Naveen have to wait in the queue. Raj complete its execution, then Naveen is going to access that resource. So what you have to do, you have to make this method synchronized. Now in Java, we can do this concept using a keyword called synchronized as well as using a block called synchronized block. But when I'm working on Python, this synchronization is actually implemented using some function called lock. Some class is there lock. So using that, we have to lock that particular thread for a particular resource for a particular thread. So how I can use that lock? What you can do is that you can use here. Can create a particular variable as self dot l equal to lock. So this is also part of threading. So threading it cannot import. So you can manually provide like threading dot lock. Now that lock we have implemented. Now when that particular thread is going to access this resource, this is my resource. When the thread is going to access this resource, then what it will do is that it will I'm just getting an object of lock here. Now for this thread will acquire the lock for this resource. So how this thread is going to acquire the lock for this resource? Okay, so what you have to do here before after starting, we have to use self dot l dot acquire. Here acquire is there. Now it right is the object of our C acquire. Now when Raj came and it acquired the lock, I created the lock. I will complete all the operations. After that, when operations completed, then what Raj will do is that Raj will release the lock. So how Raj will, on operation completed, Raj will release the lock. How to release? Self dot l dot release. Raj will release the lock. Then Naveen will go and do the same process once again. It should be like this, right? So let me check file, save all, execute, lock class, release the lock. Okay, what I'm doing is that I'm not going to subtract here minus equal to. Okay, just see here, please. Available berth is 1. 1 berth allotted for Raj. Okay, so available berth is 0. No berth is available. So since no berth is available, it comes in the else block, right? So for the next thread, so next thread will not be executed. So this is a thing, It's very good examples how we can talk about thread synchronization for reservation. Anyone want to add any input, please? Okay. Okay, so what I'll do is that we'll take a break for 10 to 15 minutes, and then after break we'll start inter-thread communication, one example, and then we'll talk about Python with data science, one project. Fine, guys.
Yeah, Medha. That's good.
Well, okay, we'll take a break for 15 minutes, then we'll start. So let's move with the next part. Next, we'll continue our topic with the thread part that I have not completed yet. The last concept that we talk about on thread, it is inter-thread communication. So let me show you my desktop here. So last time we have I've shown you that examples on thread synchronization side. So we have completed the examples of thread synchronization, and then just see where we are in our flow. We are talking about we are moving with this. Okay, so on the thread part, what you have to do is that we talk about this inter-thread communication. Okay, now, and then we'll move with the project with Python, example of data science examples, real life example projects we'll talk about using pandas. Okay, so let's move with this. Let me complete this on this part. It is also an important point. Let's complete this. So let's complete this part. This one. So as we talked about that this inter-thread communication and thread synchronization, these are the two major topics that we generally used in our real-life application. So in both the same scenario, we find that when multiple threads will interact with each other, at a time only one thread can access resource, and other thread have to wait in the queue. So that is the concept of synchronization, right? Now, when you go with inter-thread communication, this inter-thread communication is that how multiple thread will interact with each other and complete a particular task in a particular project application or case study, right? So what we'll do is that we'll understand this inter-thread communication using a particular producer-consumer problem. This is a very used problem in a very common application to talk about how inter-thread communication will work between multiple thread. So talk about inter-thread communication using a case study, that is producer-consumer problem. Producer and consumer problem. Okay. So let's talk about it. Now, what is this producer consumer problem? Is like this. Let's see. This is producer. The producer consumer problem is like producer will create some object inside a container. Assume this is the container. This is the container. And assume producer have created any particular object in the container. On the other side, consumer is going to consume those items from the container. Okay. So consumer. So producer will produce the item inside a container, and consumer is going to consume the item from the container. Now, this is the application. So think a particular real life example like producer is going to produce one bread item, and consumer is going to consume that bread item in such way that this process would continue continuously till the time like the container should never overflow with items, and consumer don't have to wait long time for the item. So like this way, the process should continue. Again, I'm saying in this producer consumer problem, producer is one thread. So this thread is going to produce some item inside the container. Fine. And consumer is another one thread. And this consumer will consume the item from the container. Okay. So the process will continue in such a way that the container should never be empty. Okay. Or neither it will be overflow with items. On the other side, consumers should not wait for a long time to consume an item from the container. So this process should go on simultaneously. Producer will produce an item in the container, and consumer should consume the item from the container. So this is one application how we can implement using inter-thread communication. This application how we can implement using inter-thread communication. Okay, so to talk about this, so just see here please. So producer is going to produce a particular item and it's a particular thread. So we have to implement the communication between these two threads in such way that it will continue simultaneously, right? Okay. So let's do it using thread application in Python. We'll implement this application. Okay. So what we have to do? We have to create a thread producer. That means you have to create a class producer, correct? And we have to create another one class. The name of the class is consumer. We have two classes. One is a producer class, another is a consumer class. Okay, fine. Now the process will come. Now this is a queue container. You can implement as a queue, so that you can also implement as a class queue, like that. So if you see here, we have total 3 classes we can implement. But before implementing any class implementation, you have to understand this flow. See, producer is a thread class. Consumer is also a thread class. As I told you that this application should continue simultaneously. That is inter-thread communication. So, right, those two threads will interact with each other with the container in such a way that it will continue simultaneously. Now here, if you see, now this application can be done different way, different approaches there. Even in Python also, you can do the same application 4 to 5 type of program you can implement, you can use to execute this application. So before executing it, let's understand it into some more details. Now see, when producer is going to produce a particular item inside a container, assume it has created an obj object inside a container. So when once it will produce the object inside a container, then after producing, it will notify to the consumer that yes, I have produced. Again, I'm saying, when producer will produce the item or create the item inside the container, once the item created inside a container, then producer should notify to the consumer that yes, I have produced the item. And when consumer got the notification from the producer that yes, when consumer got the notification from the producer, then consumer should consume the item from the container, and it should notify to the producer that yes, I have consumed. Okay, so that means to implement, one of the approach is we can use container callback methods we talked about, right, in thread application, that is called wait and notify. We can use those. This is one approach we can implement. Wait, already I told you these two methods in our inter-thread thread application, wait and notify. These two methods we can use to implement this application. This is one approach. Now again I'm saying, producer has produced the item in the container. Producer have produced the item in the container. Right after that, it will notify to the consumer that I have produced. That means number one, will after production, producer will notify to the consumer that yes, I have produced. That means notify will come first for producer. Notify will come first for producer, right? Right? Consumer that I have produced, then producer will go to the wait state. Second will come wait. Producer. Now consumer is already waiting. Already it is waiting to get the item. So for consumer, wait state will come first. Consumer is already waiting to get the item from the producer. So wait state should come first for the consumer. Now, when consumer got the notification from the producer that yes, item produced, then consumer will consume the item from the container and notify to the producer that yes, I have consumed. So the notify method should come in the second stage for the consumer. So this, if you see for producer, first notify, then wait. For consumer, first wait, then notify, right? So you can say that it is going to use put method because it is going to put one item inside the container, and it is going to use get method because it is going to get the item from the container, right? So it is like this. So if you have a particular producer class, what it is going to do, it is going to use put method to put the item inside the queue. On the other side, what consumer is doing, consumer is going to get the get method to get the item from the container. So consumer is using the get method, right? Okay, now the question is that these two threads simultaneously work in such a way that, so that means for producer thread, wait and notify will be in this sequence, and for consumer thread, wait and notify will be in this sequence. Okay, so we can use one Boolean variable for this Q class. We can use one Boolean variable for this Q class, right? Item. We can create a Boolean variable for this class and show that changing the Boolean variable, we inside the Q class we can we have put method we can create inside a put method. I have for producer it should be execute first notify, then wait in this sequence, and in the get method first wait and then notify. In this sequence it will get executed. Okay, so this is the the scenario for the producer consumer problem and its structure. Okay, so let me tell you once again before going to the implementation. We are creating inter-thread communication for a particular producer consumer problem. So in this inter-thread communication, producer will produce the item, consumer is going to consume the item from the container. So producer will put method to put the item in the container. Consumer will yes, please. Anyone is saying anything? Okay. Consumer. Yes, please. Any question, please? Okay. Okay. Now, how we can implement this? We have to create a producer thread. We have to create a consumer thread, and on the Q class, we have to use for put method for producer first wait and notify will come, and in the get method wait and notify will come in this sequence for consumer thread, right? So this is the basic structure how this producer consumer problem will execute, right? Okay, so let us implement this one. Let me write the Python code to implement this one. So just here, please. So first, what I'm going to do, I'm going to write producer class. So write class producer. Okay, so I'm going to write the producer. In the producer class, you can write one constructor def init. Okay, and you can use self to define this producer thread in the producer thread. Right, one constructor you have defined in the producer thread, right? Okay. Now similarly, we can create one consumer class consumer, right? Similarly, in the consumer class also, you should define one default constructor in it, and you can use self like this, right? Okay. Now here, this producer and the consumer. Now here, if you see, it's a thread application, right? So already we know for thread application, you have to import the thread packages, and we should have another one Q class, right? So one Q class Q. Okay. Now the thing is that we can implement it use creating a separate Q class, or you can queue. There is a separate one data in Python, there is a separate data structure called queue. I can use that data structure also. So for the timing, what I'll do, I'll use the queue data structure that is provided by our Python in Python API documentation. You'll find one queue data structure. I'll use that queue data structure to implement that functionality here. Fine. So so I can print producer thread. You can create the queue. Get self dot queue equal to. I'm using this queue data structure provided by our Python. Now, what producer will do? Producer is going to produce the item. Okay, so I have to define a particular produce method or put method. Let me define produce method self. Okay. Now here, what I want to do? Assume it is going to put the item from a particular range, like 1 to 10 item. I want producer to produce. Okay, so it's going to produce the item for I in range between 1 to take 11. This item it is going to produce. So you can write here like print something. You have to print like item produced or something like that. It will print in the console. Item produced. Okay. Now which item it got produced? That item also you can provide. That item it is going to produce, right? Okay. So that you can put inside queue. So you can use a queue, the instance variable here. Put that item that it gets produced. Okay. Now here in the consumer, it is got consumer is going to consume this item. Consumer is going to consume the item that is produced by the producer. Fine. So for consumer should take producer object, then only it can get the item, right? So what I can do is that here you can create a separate method called consumer. For consumer, is going to consume the item. Okay. So going to consume the item. So the method, right? This is a self method, same like produce, right? Now it's going to consume the item in the same loop structure. Okay. So use that loop for I in range between 1, 11. Okay. And print, it can print that it got consumed. And received item, you can say, received item. Okay. And you can define that as, now here I can take a parameter as produce, and this parameter I can initialize here using self dot prod equal to, so to get the parameters constructor, we can create a particular instance variable as prod, and from that instance variable it's going to get the item here. So define self dot prod. Queue it is going to put queue object, so it should take the item from queue dot get. Right? Okay. This is the basic structure. If it is, then I can create the object for consumer like P equal to producer. Okay. And you can create an object for consumer also like C equal to consumer. Okay. The consumer is taking an object of P, right? Okay. Both the object is started. Now, how we are going to start? I've not started. I've just created that about the class, right? How are you going to start? So first you have to start the P, then you have to start the C. So where is the thread? This is the third implementation. How we are creating this problem? Third implementation of thread creation, right? So in the third implementation, how we create? First you have T1 thread and create here as target. What is the target? Target is produce, right? Target is produce, right? So you can use P dot produce. Similarly, second thread we should create for consumer T2 equal to thread. Here its method is consume. So target equal to C dot consume, right? Right. Now you have to start with the thread. Let's just start with the thread. T1 dot start. Zero to start. Then it should work. So I think everything is fine. Producer class. Okay, we have to import those things. So we'll do the import, and when I'm going to execute the program, just see here, please, and come to there, and you have to. Last time I created this example. File, save as, and use it as a thread 6. Hi. Okay. So already we know that when you can get a thread program, we have to import that. Which one we have to import? I import threading. Okay, and then I'm not use any slip method. Not required. Okay, you have to import queue also. Okay, so this is my produce method, producer method. So in the producer method, I have constructor, and then we have this method. Let me just complete that indentation first. This one. On the other side, this is our consumer class. The consumer class, I have to define this class. And here I have in parameterize constructor. Then I have to create another one method inside the consumer class, consume. Going to consume in the same loop structure. That's it, these two. Now here, this is my thread object we have created. For the thread we have created, then with the thread we have started. For the thread we have started. That's it, save it. File, save all. Okay. Fine, nice. Here some producer has some issues like what is saying unexpected indent. Okay, so this is my class. Okay, threading I have to okay, so that these things is not imported, so not working properly. Control C. So for your thread you have to use threading dot. Okay, and for your queue, you have to use queue dot. Okay, I think it's okay, fine. Consumer, producer, in this is the constructor for producer, constructor for consumer. Consumer is going to have the item using get, producer is going to item using put from the queue, fine. And where you have created that queue you have created inside this queue class. It's fine, it's okay, I think it should work. Let me check, let's execute. Okay, so just see here guys, item produced. Okay, where is item consumed? Receipt item, but it should work simultaneously, right? So just see here, is there anything else? You have this is the queue, inside a queue instance variable, fine. This is the producer method. Moving from this range, it is producing the items. So when it is producing the item, it is putting the item in the queue. Once it's then you can put one slip phase here. Okay, you can put one slip and go wait for a sleep for 1 second. So sleep is a part of our time package. So import time. Okay. Okay. Now when consumer comes, consumer for instance variable we have defined as prod, and in the consume method it is moving through this loop, and between the same range, and it will receive the item. Once it will receive the item using get method, right? I think it's correct only. Is just here please. It's working. Item produced and received. Producer produced the item and it moved to the wait state. Consumer consumed the item. Again producer produced the item and consumer consumed the item. Producer produced the item, consumer consumed the item. So like this way it works simultaneously. See here. So that you will not get the container empty, neither container will be overflow with item. And this process will simultaneously continue like this way. Now in these examples, we have used the queue class to implement queue we have used here to implement this process. And it's a very, very good examples of inter-thread communication, right? Right, so you can try in your system. So I'll share all the code with everyone. Fine, guys. Anything else anyone want to add?
Yeah, Amitav, I have a doubt here.
Yes, yes, please.
Yeah, you just passed a parameter. You just gave an object to the consumer class, right? And you passed a
Yes.
parameter that is P. So
Yes,
what
correct.
can you please explain, elaborate a bit on that? What parameter and exactly how does it work? That particular part.
Okay. Now the implementation is here. This can be done is using that wait and notify method. Also, in this case, we have used the queue class. Queue. So in the queue architecture, what happened? If you know, it will follow the pattern FIFO type, right? So here, when the item is produced, where that item you have produced in the queue, item is producer, I put the item in the queue. So what is the queue architecture here? First in, first out. right? So the item already been inside the queue, and that item being connected by the consumer from the queue. So it can get the item from the queue only when you'll provide the reference for prod, because this producer here I've get a reference. It's actually not prod, any variable you can take it. Just to point out that queue, I have used this variable here. So that's why prod.queue.get we have used. So the item that came inside the queue, and I have to get the item from the queue, fine. So that queue, just I have to connect to that queue with producer to consumer. I have used this prod. That is only the thing. Prod has no such importance here. Just to connect the queue with producer and consumer, I have used this prod. Things are going inside the queue. Producer is going to produce the item inside this queue that we have created, and consumer is going to get the item from the queue. So a queue actually working. So to connectivity, to create the connectivity of the queue, we have used this prod actually with the consumer and producer. That is only.
Okay, so basically for the consumer class, we are calling the object of the producer class, and that's why the queue is being called here. Prod is pointing to queue. That's the connection that has been established, right?
Just the connection it's establishing, not more
Okay.
than that. Actual
Yeah.
task is done by this queue only. This
Queue.
is actual task. First in, first out approach. The object that came first, that is going to get. See, this is one approach given here. Similarly, it can be done using wait notify also. We can use the same examples using wait notify, but in this wait notify implementation, you have to write huge amount of code. But since in our Python data structure, they have that queue architecture, so it is much more faster and without writing very less number of code.
Okay, thanks, Amita.
Okay. So guys, let's move